So hello students, so today we are going to study the chapter refraction of light. Now what is refraction? Light has various properties. Reflection, which you have studied in your class 9. In class 10 we are going to study refraction. What is refraction? As well as we are going to study dispersion in detail. So basically, what is the definition of refraction? You can note down the definition. Refraction means when light changes its direction. Light changes its direction from one transparent medium to another transparent medium. That is called as refraction. So definition is light changes its direction when going from light changes its direction while going from one transparent medium. So medium should be transparent. One transparent medium to another transparent medium. So light changes its direction while going from one transparent medium to another transparent medium, and this is called refraction of light. I will study that is change in the direction while going from one transparent medium to another transparent medium. Transparent medium, example of transparent medium: air, glass, water, diamond. So these are example of transparent medium. So we will study, as per your syllabus, refraction of light passing through glass slab. We will discuss refraction of light passing through glass slab. Refraction of light passing through glass slab. This is a very important question. Firstly, we'll draw a glass slab. So this is the glass slab. This is air. Now air is rare medium. We can say rarer medium, whereas glass is the denser medium. Why it is denser medium? Because the molecules in the glass are closely packed. So we can call it as denser medium, where molecules in air is not closely packed. We can call it as rarer medium, denser and rarer. We'll draw a normal. Normal is nothing but a perpendicular line drawn is called as normal. We'll drop this part. Now let us name this slab as PQRS. This is the normal. Normal is the perpendicular line drawn. Now this is the incident ray, incident light ray. Now if there was no glass, definitely it would have gone straight. But since, see, this is air, this is the incident light. If there was no glass, it would have gone straight. but it enters glass. So what will happen? The incident ray has changed the medium. Now what is refraction? When there is a change in the direction, there is a change in the direction when medium is changed. So what will happen? It will change its direction. So this is the direction. Instead of going straight, it bends towards normal. What happens? It bends towards normal. This is the incident ray, and this one is what? Refracted ray. What we can observe over here, when light ray enters from rarer medium to denser medium, what will happen? Refracted ray, instead of going straight, it will bend towards normal. So this is rule 1. So what is rule 1? You need to learn the rules. When light ray enters from denser medium, when light ray passes from rarer to denser, when it passes from rarer to denser, what will happen? It will bend where? It will bend towards normal. This is the normal. So when light ray passes from rarer medium to denser medium, it bends towards normal. So this is rule 1. Now what we can see, now this angle, we have to write down the angle with respect to normal. This angle is angle of incidence, and this angle is angle of refraction, denoted by R. We'll name it. Let us consider this point A and this as point B. So AB is the incident ray, B and this point is C. AB is the incident ray, BC is the refracted ray. Again we'll draw one more normal over here. Now this ray is going to come out of the glass. That means again it will go to air. Air is a rarer medium. Now instead of going straight, what will happen? It will move away from the normal. Let us name it as CD. See, light ray, incident ray AB, when it enters glass, glass is a denser medium. So instead of going straight, it will bend where? Towards normal. Now again it comes out of the glass. Now it is entering from denser to rarer medium. Instead of going straight, what will happen? It will move away from the normal. So second rule, what is rule 2? Rule 2 states that when light ray passes from denser to rarer medium, it moves away from the normal. So diagram for this, we can say this is the normal, this is the incident ray. Instead of going straight, it will bend where? Towards normal. For this we can say when light ray enters from denser to rarer medium, this is rarer medium, instead of going straight, it will move away from the normal. So these are the two rules. One more rule is there. When light ray is incident normally at the boundary between two media. Now rule 3. This is glass, this is air, this is the normal. When light ray is incident obliquely, now the light ray is incident normally. Now when it is incident normally, it will pass through the glass surface without any deviation. I mean without change in the direction. So rule number 3, when light ray is incident normally, when light ray is incident normally where? Between two surface. This is called as interface. What is interface? The boundary which joins both the medium. So when light ray is incident normally between two boundaries, when light ray is incident normally, we can say there is no change in the direction. So these are the 3 rules. When light ray is incident normally between two media. Which two media? Air and glass. There is no change in the direction. Now what we can see over here, to refraction of light through glass slab. This is the diagram. Through a glass slab, what we can see, incident ray AB, when it enters the glass, what will happen? Initially it was in air, that means it was in rarer medium. When it enters a denser medium, instead of going straight, where it moves towards normal. So this is what refracted ray. Now when it comes out of this medium, I mean when it comes out of the glass, now instead of going straight, it will move away from the normal. Why? Because now it is entering from glass to air, I mean dense to rare. So when light passes from denser to rarer medium, it moves away from the normal. So we'll call it as E. E is what? Angle of emergence, and we'll name CD as emergent ray. So after drawing this diagram, you need to write down AB is what? Incident ray. BC is what? Refracted ray. Then CD is what? Emergent ray. Since it comes out of the glass. Then I is angle of incidence. R is angle of refraction. And E is angle of emergence. So this is what the diagram for refraction of light through a glass slab. It's very simple diagram. And one more thing, normal. We'll name the normal also. We'll name it as Mn, and this one M dash N dash. One more thing, we can say Mn and M dash N dash. These are what? Normal. After drawing diagram, we need to write down these things. Then only you'll get full marks. So this is what refraction of light through glass slab. It's a very simple diagram. I'll repeat again shortly. See, you need to draw a glass slab. This is the normal. This is the incident ray. When it enters from this is air, this is glass. Now when it enters from air to glass, I mean rare to dense, instead of going straight, what will happen? It will bend. It will bend towards normal. This is the normal. Okay. Now after this, again draw a normal. Now again it comes out of the glass. Instead of going straight, it will move away from the normal. Why it will move away from the normal? Because when light enters from dense to rare, it will move away from the normal. So this is what refraction of light through a glass slab. Now we'll study laws of refraction. Now, what are laws of refraction? This is a very important topic. Sorry, we'll draw it again. Now, when light ray enters from air to glass, this is the incident ray. We'll say AB is the incident ray, BC is the refracted ray. This is what angle of incidence, this is angle of refraction. This is the normal. What we can see over here, see, this is the normal. This side we can say what? Incident ray, and on this side we can say there is refracted ray. So what we can observe, incident ray and refracted ray, where they lie on the opposite side of the normal. On this side of the normal we can see there is incident ray, on the right side we can see refracted ray. So this is the first law. We can say incident ray and refracted ray, incident ray and refracted ray lie on the opposite side of the normal. Where do they lie? They lie on the opposite side of the normal. Second point, now incident ray, refracted ray and normal, incident ray, refracted ray and normal, they lie in the same plane. So second point, incident ray, refracted ray and normal lie in the same plane. Then third point, see, this is I, angle of incidence, and this is what? Angle of refraction. See, this becomes 90 degree. Now what will be sine of I? Sine of I will be what? Opposite upon, sine is what? Opposite upon hypotenuse. Sine R will be opposite upon, we can find out opposite, this is opposite side, this is opposite, and this will be hypotenuse. So what we'll find out, see, derivation, it has a separate derivation in your 11th science. What we can observe, for a given pair of media, for a given pair of media, I mean after taking different angles, here angle of incidence will be greater than angle of refraction, And for a given pair of media, after finding out angle I, what you can observe, sin I upon sin R, sine of angle of incidence to sine of angle of refraction is what? It is always constant. So what you need to write down over here, for a given pair of media, simply you can write down sin I upon sin R is equal to constant, or you can say the ratio of sine of angle of incidence to sine of angle of the ratio of sine of angle of incidence to sine of angle of refraction is constant. Or simply you can write down, for a given pair of media, sin I upon sin R is called as constant. This is called as Snell's law. Sin I upon sin R is equal to constant is called as Snell's law, and this constant is called as refractive index. For exam, you can write down laws of refraction: incident ray and refracted ray, where they lie on the opposite side of the normal. Incident ray, refracted ray and normal, they lie in the same plane. And third point, for a given pair of media, the ratio of sine of angle of incidence to sine of angle of refraction is constant, and this constant is called as refractive index. See, we'll discuss in detail in class 11 science about this derivation. For the time being, I will not elaborate this part. I will make a separate video for 11 science. In that, I'll explain in detail. So what you need to write down for laws of refraction: incident ray, refracted ray lie on the opposite side of the normal. Then incident ray, refracted ray and normal lie in the same plane. And third point, for a given pair of media, sin I upon sin R is constant, and this constant is called as refractive index. This law was put forward by Snell. This is also called as Snell's law. So this was law of refraction.